right, this is lesson 3-5, all about arithmetic sequences. So basically an arithmetic sequence is a set of numbers, a sequence of numbers that you are adding or subtracting the same thing from over and over. It's a constant increase or a constant decrease. It's a steady rate. So arithmetic sequence, a numerical pattern that increases or decreases at a constant rate or value called the common difference. And as we're working on the math, we refer to that number as D. Terms of an arithmetic sequence, we have A1, D, N, or A N, right? So A sub N is the value of a term. N is the place it is in line. So like, for instance, these numbers down here, the first number in line is 12. So AN would equal 12, right? A1, it's the first number in line, so A1 would equal 12. The 1, N equals 1, tells us that it's the first number in line. A sub 1 tells us what that number is, it's 12. A sub 2 would be 15, right? Its place in line is number 2, N equals 2. But what is the number that's second in line? 15. So A sub 2 is 15. The third number in line, N equals 3, is 18. So A sub 3 would be 18. A sub 4 would be 21. So N would equal 4. And our number would be 21. So N tells us where it is in the number sequence. A sub N tells us what the actual value of that number is, right? D is what we use for the common difference. And it gives us an equation to use here. So we're really going to focus on that equation element. And I think this will make more sense as we just do it over and over again. So these are important, what the terms are and the sequence here. All right, so first off, example 1, it says determine whether the sequence 1, 3, 5, 7, 9, 11 is an arithmetic sequence and justify your answer. So what we have to do is figure out, is it increasing or decreasing at a steady rate, right? So we have 1, 3, 5, 7, 9, 11, and then the ellipsis there tells us it keeps going. Okay, so from 1 to 3, what did we do? What did we add or subtract? We added 2. From 3 to 5, I added 2. 5 to 7, I added 2. 7 to 9, added 2. 9 to 11, added 2. So as you can see, over and over, we're adding 2. So here we would say, yes, this is an arithmetic sequence. And the common difference, or D, common difference, D, is 2. If we were subtracting 2, we would put negative 2 here. But each number is increasing by 2 more. So this is an arithmetic sequence because it's a constant rate, right? Example 2, write an equation for the nth term of the sequence, 12, 15, 18, 21. Nth term means we're not saying like what's the 7th term in the sequence, what's the 7th number in this sequence. Here's the first 4, so if I kept going, what's the 7th number, right? Well, what if I don't know which number I'm looking for? What's just a general equation I can use to find any term in the sequence? That's when we're going to use this equation up here, right? So we're going to use A sub n equals the first number in the sequence, A sub 1, plus n minus 1 times the common difference, right? So for this equation here, 12 is the first number in my sequence. 12 is A1. So A sub n, I don't know what n is. I'm looking for the nth term. If it said looking for the 6th term, you would put a 6 wherever you see an n. But it says nth term, so we just leave n alone. So A1 is 12 plus, again, we don't know which number we're looking for, so we keep that in, times the common difference. What am I doing to get from one number to the next? 12 to 15, I added 3. 15 to 18, I added 3. 18 to 21, I added 3. So I'm just adding 3. So I multiply this times 3. So then I can just start simplifying, right? I'm just going to simplify until I can't anymore. So I'm going to distribute this 3. So I'll have 12 plus n times 3 is 3n. Bring down that minus sign. 1 times 3 is 3. I can combine my like terms. 12 minus 3 is 9. So I'm going to have 3n plus 9. So a sub n equals 3n plus 9. This is my equation to find the nth term of a sequence. Okay, so if we wanted to try it out, let's say we wanted to find, it gives us the first 4 terms. So let's say, just because we know what it is, let's say we want to find the 4th term in a sequence. Find 4th term. Okay, so wherever we see an n, we're going to put a 4, because 4 is the number of its place in line, right? To find the 4th term, so a sub 4 equals 3 times 4 plus 9. 3 times 4 is 12. 12 plus 9 is 21. So the 4th term in the sequence, a sub 4, is 21. And we know that's correct because it gives us the 4th term up here. Okay, so this is just a little shortcut. All you have to do is put in what place in line your number is, plug that in, and then this tells you what the actual number is. The 4th number in line is 21, so 21 equals a sub 4. Hopefully that makes sense to you, all right? We got a few exercises here, about 7. Determine whether each sequence is an arithmetic sequence. Okay, so we're just gonna look, how do we get from one number to the next? Don't just do the first couple and think you're done, because sometimes they'll put a trick here at the end of the sequence, so you just gotta pay attention. So from 1 to 5, I added 4. From 5 to 9, I added 4. 9 to 13, I added 4. 13 to 17, I added 4. So yes, this is an arithmetic sequence because I'm increasing by the same amount. So yes, and I'll put the common difference is 4. D equals 4, that's what I'm adding. Okay, number 2, to get from here to here, 1 to 3, I added 2. To get from 3 to 9, I added 6. 9 to 27, I added, 18. 27 to 81, I added, I think, 54. Right? That's definitely not adding the same number over and over. So this is no. There's no common difference. Common difference. There's no amount that I'm continually increasing or decreasing by over and over. It changes. I increase by 2, then 6, then 18, then 54. Right? It looks like I multiplied by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. But multiplication does not make an arithmetic sequence. Adding and subtracting does. Okay, let's do 3 and 4. Find the next 3 terms of each arithmetic sequence. So what am I doing to get from 9 to 13? I'm adding 4. 13 to 17, I'm adding 4. 17 to 21. 21 to 25. So the next number would be 25 plus 4, which is 29. The next number would be 29 plus 4, which is 33. And then the next number after that would be 33 plus 4, which is 37. So my next 3 terms are 29, 33, 37. Because I just keep adding 4 over and over. Okay, number 4. And it tells us these are all arithmetic sequences here, these 2, 3, and 4. So you're not trying to figure out if it is anymore. Now you know it is. So just figure out what are you adding or subtracting by and then keep doing it. So to get from 4 to 0 here, I actually subtracted 4. To get from 0 to negative 4, subtract 4. Subtract 4 again, subtract 4 again. So what's negative 12 minus 4? Negative 16. What's negative 16 minus 4? Negative 20. What's negative 20 minus 4? Negative 24. So there's the next 3 terms of this sequence. That's all it said to do. So that's all we're doing. Okay, and then finally down here, you might see some of these kind of problems on your homework. That's why I'm doing them this way. Write an equation for the nth term of each arithmetic sequence. And just as a little reminder, our equation that we use, our formula, is a sub n equals a1 plus n minus 1 times d. You will need to know that. Do we use it all the time? You're going to see it a lot more than other things that we've learned that I say we'll never use it again, don't worry about it, whatever. You actually are going to see this quite a bit. It's a helpful thing to know, and the more we do it, the more it's going to kind of click and you'll remember it. But beyond this specific lesson, we don't really focus on it that much. But you will see it a lot in benchmarks, EOCs, things like that. So you do need to remember this formula. Okay, so remember A1 is the first number in the sequence. N is what place we're looking for, which here it says the nth term, so that's just going to stay N for everything. And D is the common difference. Okay, so here AN equals A1 plus N minus 1 times D. A1 is 1. I don't know what N is. And then the common difference, to get from each of these, I'm adding 2. So it's positive 2. So I'm multiplying this number times everything inside parentheses. So I get 1 plus, once I distribute that 2n minus 2. Combine my like terms, and I get 2n minus 1. So an equals 2n minus 1. So then from there, if I said find the 13th number in the sequence, right? When it says find the 4th or 5th number, we can just keep adding or subtracting. That's not a big deal. But if I said find the 37th number in the sequence, that's going to take a long time for you to keep adding 4 over and over, or subtracting 3, or whatever the deal is. So this is a little shortcut to use, right? This little formula. All right, number 6. -1, -4, -7, -10. From -1 to -4, I subtracted 3. So, and -4 to -7, I subtracted 3, subtracted 3 again. So my common difference is -3. The first number in my sequence, my A1, is -1. And then N, I don't know what N is here. It asked me to find the nth term, so that stays N. So I'm going to plug this into my equation, right? AN equals A1 plus N minus 1 times the common difference, which is -3. So now I can just distribute that -3. -1, -3 times N is -3N. Bring down my minus sign. -3 times 1 is -3. And when I have a double minus, I make it a plus. Combine like terms, -1 plus 3 is 2. So I have -3n plus 2. That's my equation. And then lastly, again, using the same formula, here to get from one number to the next, it looks like I'm subtracting 5. -4 minus 5 is -9. -9 minus 5 is -14 minus 5. So our common difference is -5. The first number in the sequence, our A1, is -4. And then I still don't know what N is. So I'm going to use these three things to plug into this equation. A sub N equals A1, which is -4, plus N minus 1 times the common difference, which is, and make that look like a D, -5. And then, of course, I distribute. -4 plus -5 times N is -5N. Bring down my minus sign here. 1 times -5 is -5. I have a double minus, so it becomes a plus. -4 plus 5 is 1. So I end up with this guy right here. AN equals this equation. Makes sense. If I wanted to check it, it shows me right here the 4th term in the sequence. So I could plug a 4 in for N. Remember, N is the placeholder in line, right? What order term we're looking for. AN is the actual number. What is it? If I said find the 4th number in line, what is that 4th number, right? So here we would plug in a 4. -5 times 4 is -20. -20 plus 1 is -19, which is our 4th term. So this is a little shortcut equation to find a specific term. If you have any questions on that, let me know, and make sure you watch video 2.